Hey everybody, we have a trigonometric floor equation here. And let's just briefly review what we mean by the floor function. The floor function automatically returns an integer value no matter what its input is. An input can be any real number. So the floor of -1 is just equal to -1. All right. And it's the greatest integer less than or equal to -1, which is of course -1. Let's write down some more, shall we call them non-trivial examples. This would also be equal to the floor of, let's say, minus 0.8. A lot of times I'll leave the 0 up, but I think it's kind of nice to put it in. Okay. -1 is the greatest integer less than minus 0.8. And just another example would be, you could go really low, we'll do minus 0.02, something ridiculous like that. Okay, see, even though that's closer to 0 itself, the greatest integer less than or equal to it is still equal to -1 over here, okay? So those are a couple of examples of numerical calculations associated with the floor function. And we're interested in that because notice the sine functions and the cosine functions are bounded below by -1 and above by 1. Just they're defined on the unit circle, so they can't get any smaller than -1. They can't get any larger than 1. Now, this is the equation we're trying to solve. And so it becomes pretty clear based on what I've talked about, hopefully, that both of these guys, the floor of both of these functions have to be equal to -1. Because if you take 2 to the other side, that makes it -2 over here. And so the sum of this and this have to add up to -2. The only way that can happen is if both of them are equal to -1. All right. Now let's move along. Now, a couple of facts that are important from the unit circle. The sine of pi, radians, okay. And again, the sine function is just the y coordinate on the unit circle as the circle spins. Okay, but that's equal to 0. Any other multiple of pi would do. But that's also equal to the cosine of 3 pi over 2. And again, the cosine of 3 pi over 2 is just the x coordinate. And 3 pi over 2 is straight up and down on the unit circle. It's the bottom point on the unit circle. And so the cosine of 3 pi over 2 is also equal to 0. Now, when I draw the graphs, it'll become pretty clear, hopefully, what I'm doing here. Okay, and so let's just do a couple of sketches to see what motivates all this. All right, so right here we could draw a picture of the sine wave. Now you can see what I did right here. What I did is I set this input equal to pi, since the sine of pi is equal to 0, and that's going to give us some clues on when the graph is going to turn negative, okay? And so the sine wave would look like this. This particular sine wave. And this point right here would be 7 pi over 8. Okay, that point right there would be 7 pi over 8. So you can see everything to the right of 7 pi over 8 would have a floor of -1. Okay, what I mean, that's supposed to be 7 pi over 8, folks, the same 7 pi over 8 we saw for right here. If you're to the right of 7 pi over 8, and then this would be what, 14 pi over 8 right here? Anything between 7 pi over 8 and 14 pi over 8 would have a floor of -1. Okay, if you're any point in this region, remember this is bounded above by 1 and below by -1 right here, -1 and 1 right here. So if you're a number between -7 pi over 8 and 14 pi over 8, you're going to have a floor of -1, which is what we're talking about right here. We need for the sign of 8x over 7 to equal to -1. And that happens exactly once you get past 7 pi over 8. Okay? Now in a similar fashion down here, let's take a look at this. Okay, now the cosine graph looks a little different. It starts out at 1. The cosine of 0 is 1. So we get this behavior here. Like that, right? And so this would be, now right here, notice how we set it equal to 3 pi over 2, 7x over 8. Again, where are we? Yeah, the cosine of 7, the floor of the cosine of 7x over 8, if we set 7x over 8 equal to 3 pi over 2, I'm doing that because that's where we switch from negative on the cosine graph to positive, right? And so you would have 12 pi over 7 right here. Okay. Again, and that's for this function. And it's now what about right over here? Well, you could the same thing. If this were pi over 2, you would get 4 pi over 7 right here, I believe. 4 pi over 7 would be this point right here. 4 pi over 7. Think of just pi over 2 being here, multiplying by 8, you get 4, dividing by 7, you get 4 pi over 7. So you get 4 pi over 7 right here. Now that's important because 7 pi over 8 is bigger than 4 pi over 7. Okay? So folks, you see, we need both of these to be -1, but you have to be to the right of 7 pi over 8. All right, and you have to be to the left of 12 pi over 8 from these graphs. Y'all see that? And so what we get right here is our solution set. And this is the answer. The solution set would be equal to, again, on the left, it would be 7 pi over 8, because numbers over here close to 4 pi over 8 wouldn't satisfy the floor condition of -1 right here, right? So we need 7 pi over 8 as our left endpoint. Seven pi divided by 8 for the left endpoint of our open interval here. Okay. And then notice that 12 pi over 7 is smaller than this 14 pi over 8 that you see over here, right? So that'll be what limits us. The cosine graph is limiting the right endpoint, so to speak, here. And you can think of it as intersections of domains if you want to. Okay, so that would be 12 pi over 7 for the right endpoint. I think it's kind of neat. I mean, I could write down intersection symbols and all of that, but it's just easier to look at the graphs. Okay, and anyway, that's the solution, ladies and gentlemen. Okay, and again, it's kind of cool. You could just write down formally the solution to this would be 7 pi over 8, 14 pi over 8 open interval, and then this would be 4 pi over 7, 12 pi over 7. You could write down intersect, but they do intersect exactly at these points. This one right here is the constraining value on the left, and again, 12 pi over 7 is the constraining value on the right. Any number in this set, not including the endpoints, would solve this original equation. Okay, that is all, folks, and I hope you like that. Let me know what you think.